solid or dashed, and then I'm looking for shading, okay? Those are the two additions to what I was doing before. So here, remember, if there's a number in front of the x like this, I need to factor it out, yes? Yes. So I've got f of x greater than or equal to negative 1. 3x plus 2. Oh, you're watching. Okay. All right. If I take this out, and you can take it out, you can leave it right there. It doesn't matter. If you take it out and it's negative, it's going to become positive. But in this case, it's positive. There's already a negative out there, so I'm going to have a negative 3x plus 2 plus 1. Anybody confused so far? All right. Now, I want to find the vertex of this, yes? What is the vertex? Negative 2, 1. Is anybody confused about how I got that point? All right. Negative 2, 1. Oh, okay. Where are you confused, Sawyer? So the vertex is the opposite of this, the same as that. That's it for the vertex. It's that easy. I just want to show y'all this for just a minute. Look what it says.
I don't believe it. That is white. That's yellow. That is yellow.
Look, that's yellow.
Put beside each other. Oh, it does look a little light greener than on this. It does. I was trying to speak.
Okay. This is what I got it on. That's just green. I don't know. It doesn't green. Okay. Now, I've got the vertex. I need another point, right? So what point am I going to use? Okay.
-3.
I'd probably pick -1, but you could plug in 1 if you wanted. Okay, here's what I'm going to do. I'm going to look at my vertex right at -2, and I'm going to stick close to it. So if I'm at -2 right now, what's close to -2? -1 or -3. It doesn't really matter which one you pick. Pick one, yes? All right, I'm going to plug that in, and it will give me my y value. In other words, if I do f of -1, if I write it that way, is anybody confused? Okay. No, but just be able to recognize it. Then I get negative, and I have 3 times -1 plus 6 plus 1, which is negative. Okay, what? Inside the absolute value, I can't. I can have one outside, though. I got to wait till I think about them like parentheses, and at the end, then you change it right. So this would be negative absolute value of 3 plus 1, which is -2. So this point is -1, -2. Yes? Now watch what's happening as I graph this. -1, -2. If I reflect it, yes, and I connect, first of all, is it solid or dashed? Why? There's a line under that inequality sign. That tells me solid. Right. Now my question to you is, does it look right graphed based on the equation? In other words, look at that A in front. What does the A tell me? That it's going down. Does mine go down? Yes. And then the 3 in front would make it a little bit skinnier. I don't expect you to be able to see that just yet right now on that, but that's okay. All right, now the shading. How do I know which way to shade? The greater than or equal to. So it says greater than, right? So that means I need to shade. If it says, some of you were confused about this yesterday. F of x is the same thing as y, yes? The alligator mouth eats the bigger number, right? The alligator mouth is eating the y. Where does the y get bigger? Outside of the absolute value or inside the absolute value? Outside. And that's how I know my shading. Around it, yeah. Around it. This transformations. Okay. Let me tell you about, yeah. Yes, because Max, there's any 2 points make up a line, right? It doesn't matter if I pick this one and this one for this line, or if I pick this one and this one way down here, they're still going to connect to make the same line. So yes, it doesn't matter. Other questions about that while we're here before we, oh, okay, switch gears here. All right, let's switch gears then to some transformations. Does everybody feel okay about absolute values before we move on from that? Graphing, yeah, so graphing and shading and dashed and solid and so on and so forth. Okay. See this little blue sheet? Does everybody have a little, yeah. If it's like this, it's dashed. Everything, and if there's a line under it, it's solid. He asked dashed or solid. All right. Blue sheet, you get but one. If you lose it, if you lose this, I'm sorry. You'll cry. I'll feel bad, and I'll say I'm sorry. But you still lost it. I mean, you just have to keep up with it is what I'm saying, okay? Because you might, who cut this one? You stacked them, didn't you?
Aubrey, you cut out one of my equations.
If you did, I'll give you another one. Is it okay? Okay. This is gonna be your function transformation Bible. I will probably let you use it on the quiz, and as you go along, not the test. You'll have to learn it by then. But
You have to learn this by then.
the test, yeah. Oh, you'll see, they're not hard. Have y'all not done transformations of any kind yet? We'll do so many of them that after, I'm telling you, after your project, you won't even need this anymore. All right. I do think I have on my planner to assign it tomorrow. So every unit, we don't have kind of a cush assignment to go back and help with the test grades. But this one we do have the projects, and as long as you follow suit, and we do it in class. I'm not a big send project home kind of person because y'all always hated when my kids came home with projects because it was such a stress and everything else. But anyway, I have some poster boards, I have markers, I have all the materials that you need, unless you're just picky and like a certain color marker or a certain brand or whatever. We will take probably 2 to 3 days in class, maybe 3 to 4, and they will be project work days, and we will get them done. And now, if you want the extra like bonus creativity points that you can get, for instance, like the 3 that are big there on the board were definitely bonus ones. That scary movie one, I think she had like 170 equations in that thing or something. I cannot remember. Outrageous. But if you want, the average ones are over here. I have a ton of examples. I just haven't gotten around to putting them up. But okay, so like the big posters there were like extra points. The ones up top, like the stitch, the friend, the girl. See the girl, like the watercolored. Like the second one down on the left. I'll tell you the stipulations. Oh yes, the Picasso girl. So this girl's in calculus now, and they just got their last project that they'll do for me. And so she's going to do the same thing, but we're doing cross sections. Y'all won't understand that. But anyway, she's going to do the same one, but in a calculus, so it can be, she wants me to hang it beside, so this is where it started, this is where it ends. Okay. Anyway, Hannah Pottinger. Hannah Pottinger. No. Y'all don't understand. When I teach y'all for 3 times, when y'all go, oh my gosh, my heart. Okay. Huh? I can't even think about it. Huh? She did the Friends one. So we're kind of dorks. We Friends and Gilmore Girls. We are like bingers. Okay.
I love Gilmore Girls. I watched it too many times.
Even though I know it's probably not going to happen, I made Lindsay apply to Yale and Harvard. My glory. Okay.
She might get in. But she does.
I can't afford it if she does.
She's
going to USC. She's going to USC. Her grandma paid the application thing for funsies. Okay. Now. You have to pay to apply everywhere. All right. I guess we just jump into it.
You're just gonna throw it to the pool application?
Oh, just wait. My little friend.
Are you just throwing
That's your homework. That's like the package you're going to do. I would take it. Why? Don't be scared. I wouldn't take notes on there. I mean, you could on the bottom. Did Edwards do that again? Oh. What? Brother. Tell him again, Worth. We do it on Desmos first, and then you just transpose it onto poster. Yeah. It's not bad. It's really not bad.
Katie made it seem really bad, but we don't.
I can't remember. I'll have to let you know. It's like 5 or 10 points. I can't remember. It would go on that, but it's because I do points and not percentages. It's all the same, whether I put it on there or something else. Sometimes I'll just create a whole column and say bonus points or something and put them in there. All right, ready? The donut and the penguin are pre-cal. They're unit circles. All the circles are pre-cal.
You go to the campus back.
Wait, is the clock?
Seriously. Because we have to do all the trades and the logs and the everything else and everything that I don't like in calculus, we have to do in pre-calculus. So. But then we get to calculus. I love it. Okay. Oh my gosh, it's so much fun. We revolved shapes around an axis today. We took a two-dimensional shape and we made it three-dimensional and we put holes in the middle of it and we found its volume.
Yeah, that's not.
It's fun. And look, this is where we are. Oh, we're done. We're done. I mean, we'll spend 3 or 4 days working on it. It's year long, so we can spend a longer time on stuff. Anyway, okay, parent functions. 3 of them. I'm trying to recruit for calculus. 3 parent functions that you're going to be responsible for as of right now, and we will keep adding to these. Yay! The first one. The first one is a linear, okay? And this is something that never goes away. Pre-Cal just took a test on, I think, 15 parent graphs with their... Because it's parent graphs. I didn't get it either, Sawyer. But I was like,
No, it's not right.
These are called parent graphs because they are before we do anything to them. We're going to talk about sliding, flipping, stretching, shrinking these graphs, but we have to start somewhere. The parent graph is where we start, okay? So the first one we're going to talk about is linear. You should know this one like the back of your hand. This is easy, right? A linear function that has no slides, stretch, shrink. It's just y equals x. And it just looks like this. While I am here, what is the domain of this function?
Negative infinity, infinity.
What is the range?
Negative infinity.
Look at y'all, so smart. You're welcome. Okay. That would be nice. But there's only going to be 3, and you can probably guess the other 2. Q? Quadratic. And yes, you're exactly right. Those are the 3 functions that you're going to use for when you look at the projects around the room, those are the only functions that they use. Linear, quadratic, and absolute value. And those are the 3 we're going to focus on with our transformations. So let me show you quadratic, which you should know. So the parent function for quadratic is just the x squared. That's it. It goes through the origin. 1, 1, negative 1, 1. Shoop. You gotta make that sound when you draw it. Shoop. Yeah. No problem. That's a wonky looking quadratic, but you get the point there. What's its domain? Right, because this is left to right, right? Negative infinity to infinity. How about the range? Inclusive, exclusive? Inclusive. Does it include the 0 or not? It always, unless there's an open dot right there, it's always inclusive at the bottom. One thing while several of you are copying that, I was helping some pre-cal students today at lunch with some domain and range issues because they're also doing piecewise, but they're doing like piecewise on crack. It's like, but with domain and range on where I start and what I leave out, right? I don't know why I've never thought to do this before, but geez. For range, if you flip your paper up and let that be a line, whenever you start working up the graph, when you hit graph, that's where your range starts. And then as long as you go up, as long as you're still touching graph, you've still got range. So that one goes up forever, so it'll be 2 infinity. That'll really help you with your piecewise. I'll show you on a piecewise shortly. And anyway. Just like you did your pencil, but sometimes it's hard to see. If you use the edge of your paper to go left and right instead of the pencil, it's a little easier to see. It's pretty cool. Okay, last one. Absolute value. Quadratic, yep. This is just the absolute value. Oops. My brain was thinking there's no A because there's not. The absolute value of x. Notice there's no numbers in front. There's no numbers added or subtracted, multiplied, any of that, because that's going to be my transformation. What does this look like when I graph it? I'm just glad you asked. That's right. Absolute values. Everybody okay today? Oh, okay. Well, I'm sorry. Now let's do some math. What about the domain? Yes. How about the range? There's, yes, look at.
1 times 1 point.
Yep.
1.
Yes.
Are you gonna mark
I mean, show me what you mean. All right, yeah. Okay, y'all ready to transform them? Willie Mae's ready. Excited. You would put the equation there. Or, I mean, same thing. It's okay. All right, let's talk about the transformations that we have. I am going to reference your little blue sheet and tell you how to read it and how to use it, okay? And then I'll do some examples with each one. So we're going to start, I think today we'll do shifts up, down, left, right. I don't know if we get to reflect. Oh, no. Okay, that's really increased in technology since.
Wait a minute, is there some type of computer that reads the data from this?
Oh my gosh. Seriously. I hope it goes off in the nighttime.
I didn't know what it was.
Oh no.
I didn't know either. Well, like, I feel like I knew it.
Yeah, I'm all ready now. Okay, we're gonna do translations of parent functions. This whole thing is, oh, I didn't write, I just wrote parent functions. Okay, this whole lesson is transformations. I just make a new title. Transformations. And I'm going to run through types of transformations. Translations are a type of transformation. You with me? Okay. Those are all types of parent functions. So it really is different topics. Okay, so we'll keep adding on to this. Like we'll add different types of parent. I would make a new title of. Now we're going to talk about transformations of parent functions. We're going to add more transformations or transformations. I mean, we won't add.
Hold on. Transformations of.
They're just freaking out because they put their little title. Yeah.
But it's transformation. Parent functions, then transformations, then translations are like, what is?
Yes, so we're talking about its parent functions, and now it's a whole new thing. It's transformations of parent functions. Technically, you should have already known parent functions, like those three. I showed it to you like you didn't know them. That was kind of like a background thing on parent functions. And so we're going to talk about 1, 2, 3, 4 types of transformations. The first being translation. Y'all like to be organized, don't you? Yeah.
We take like a 2-minute break.
Y'all been on break since we got in here, What, Max? What?
When are we starting our project?
Oh my gosh.
Motion for a 2-minute recess.
Motion grant.
I don't know that you won't have enough information to start it tomorrow.
Don't get your life together.
Huh? Tomorrow's probably strengths and stretches. I'll have the video.
Everyone that agrees said aye.
All right. Translations. Let's talk about translations. If you rewind back to geometry, who'd y'all have for geometry? Okay. It's a slide. This is nothing more than a slide. These are the easiest. I don't like a capital. I'm gonna. It is the easiest transformation we have. It literally just slides everything. Okay, so I'm going to show you what it looks like in equation form. I'm going to show you what it looks like on a graph, and I'm going to show you how to recognize it, all right, and how to find those points. So if you look at the first, we'll do vertical ones first. Yeah, I've not had a group that really liked to be organized in a long time. So this will be point A of number 1. Vertical translations. Most people I would just, yeah, it's okay, it's okay, it's okay, it's okay. I'll start doing Roman numerals if we need to. I love it. Okay. All right. Vertical translations are the first type of translations that we're going to talk about, okay? Vertical meaning up or down. Okay? Now, what does that look like? If you look at your blue sheet, the first one says function notation, right? And it says f of x plus c or f of x minus c. And you might look at that and go, what in the world does that mean? Well, I'm glad you asked, because I'm going to tell you. If you take a number, c is just a number, okay? If you take a number and you add it on the end of any equation, any number in the whole world, and you just say, whatever my equation plus 5, all it's going to do is take whatever equation you had and slide it up 5 units. Every single point on that graph slides up 5. Do y'all remember doing this?
Yes.
Okay. It's all of the points in the function. So let me show you. That is quite distracting. Okay. Look at this equation. First of all, tell me what the parent graph is. X squared, which is a quadratic, right? X squared. Do you see that I took that equation and I just threw a plus 3 on the end of it? Agreed? That means I start with the parent graph. So let me just sketch the parent. 0, 0, 1, 1, and negative 1, 1. Yes? I'm even going to label them 1, 1, 0, 0, negative 1, 1. All right, this is the parent. This is x squared. Now what I'm going to do, I should have written this in another color so you can see where it goes. Now what I'm going to do is I am going to graph, rewriting it. I'm just rewriting it in blue. Now what I'm going to do, because this plus 3 is on the end, every single point just slides up 3. So in other words, this one's not negative 1, 1 anymore. What would it become? Negative 1, 4. Instead of 0, 0, this one's going to become 0, 3. And instead of 1, 1, this one's going to become this is this graph. It literally just takes it and slides it, whoop, up 3. Okay.
So you just add 3 to every single one?
Every single one,
Why?
but only to the y's. Look at the change column. You see where it says change? And it says x, y, and it's got a little arrow, and then it says x, comma, y plus c. That means, that means take every point on the original graph, right? Let's say we started with 1, 1. Sawyer, you asked me about this. You are telling a story. You're laughing at that poor baby. If I take the point 1, 1, right? And it says I keep the x the same, but the y plus that c on the end. There you go. Lemon squeezy. Okay, just easy peasy. Just easy peasy. When we put them all together. Okay. What is the domain of the new one? The new negative infinity to infinity. What is the range?
Not 0. 4. Yes, 3.
Hold on, let me do this one. What's the range? 3 to infinity. Oh, it's 4. It's 4. Y'all are getting me distracted. Where do? No. What's the lowest it grows? What's the lowest it goes? 3. 3 up to what? Infinity. All right, give them your attention for just a second. They've come here to deliver something for you. Twice. Okay, bottoms up. The lowest the blue graph goes is 3, and then it goes up to infinity. Go with me? All right, let's slide another one. You ready? All right. Describe the transformation and tell me the domain and range. Mark, set, go. Yeah, this is
And it's always negative 1.
Oh, I thought you were fixing to tell me something about me. I said, what are you telling me? Note paper. Oh, wait.
Would you put like
Yeah. Translation
When
skill.
you do
What's up?
parent functions, you just put absolute value.
When you what?
Do you put absolute value?
Put absolute value of x. So the parent would be this. You don't have to draw the parent, no, unless you need it. The parent is just the 0, 0, 1, 1, negative 1, 1. Okay, some of you are going on with it, and some of you are going, I have no idea what's even going on right now. I don't know where I am. Okay, so what is happening? Tell me in words what is happening. It's sliding down 2. Literally, just if you could put your fingers on it and go, whoop, down 2, that's what it would do, okay? So this is a slide. We call a slide a translation, but it is just going down 2 units. Every point on the parent graph will just get moved down 2, okay? So if you think about where that parent is, I'm 0, 0, 1, 1, negative 1, 1, and from, you just have to know the parent.
0, 0, 1, 1.
Yep. Negative 1, 1, and 1, 1.
But I got, so what I don't.
What? That's the parent graph. That's what you get at
Like I did the
that's what this is.
I did actual like work it out.
Oh, yeah, don't do all that. You did the actual, oh, you're saying you graphed it, yeah. Huh?
So easy.
I'm glad you think so, Sawyer. Shh, shh, shh. Listen. You move this one down because it's subtracted. All right, so look. 3 is what?
Oh, it was 3.
All right, looking at my new graph, my transformed graph, it's been transformed by a translation. Does everyone hear the vocabulary that I'm using here? My parent function has been transformed by a vertical translation down to. Yeah, but I want you to understand all those words that I'm using. If I use them, you know what I'm. Okay. My parent function, listen, my parent function has been transformed by a translation down to. This is your parent function. Right now, you have three possible parent functions is all I'm giving you right now. It's those three we started with, either linear, quadratic, or absolute value, one of the three. All right. What's the domain? New one. Domain is negative infinity every single time. For everything we're doing right now, yes. How about the range, bottom up? Yes. Always a bracket.
Oh, yeah. We need to know, is it always going to be?
Hold on. One. For the parent, yes. Those are always the ones you're sliding.
Is it always going to be closed circle?
Yes. These are all closed circle and always will be. I know. You have told me 5 different times. Okay. We will miss you, Max. Thank you for letting us know. Okay. Let's do. Let's do a horizontal translation. And then we'll put them together, and then I'm going to give you some that are actual graphs. So this was what, B? It looks that way. Oh, that's my fault. I take so much fun. Never ever have one. Yep, it's happening right now. Thank you. It's really nice. All right, you ready? That was vertical. Now this is horizontal. Okay. This is also a slide, but this is a left or right slide. Okay. I think you're going to see about the vertex form and stuff where that's coming from in just a second. All right. What is?
It can be more than linear.
Okay. If you look at your cheat sheet, lines 3 and 4, notice it says f of x plus c or f of x minus c. Okay. This one is a little bit different. I'm still adding and subtracting, but this time it's only x. It's not just thrown on the end of the equation. And it's the opposite of what you would think. Did I write them backwards? Oh. It's the opposite of what you would think. If you add a number, it is sliding us to the left. But if you subtract a number, it's sliding us to the right. So it's the opposite of what you would think, okay? That's where it starts. Everything horizontal with transformations is opposite everything, and it is so aggravating, okay? All right, let me show you what I mean and what this looks like. Now notice on your change column there, this time, you have your X and your Y, and it becomes... This time I'm only adjusting the X, right? But if I'm adding C here in the actual coordinate, I'm subtracting C, but leaving Y alone. This is just what you have to do. How does opposite? You have to remember X is opposite and it will help you. X is opposite, X is opposite. It's opposite when we do dilations and compressions and stretches, and X is always opposite. Okay, if you remember that, it'll help you. So if, yes. Okay. I think I'm understanding what you're saying. Yes, on the vertex, Riley Grace, on the vertex, yes. Yeah, if you don't need this column you will utilize that a lot more when we start combining everything and you start getting confused, and you'll see shortly.
Oh, it's on our paper.
It's on your paper. All this is on your paper. Okay, let's say we'll start. Okay, what is the parent graph? X squared. You should see that squared and automatically go, it's X squared. So the parent is X squared. Now, what has been done to that parent graph? It got +1. This is what it looks like when it's hooked to the X. This is not the same. It's not the same as that one, okay? This one is up 1. This one is a left-right shift. Do you see the difference? It's because it's in parentheses with that operation, okay? Okay. This is not the same. All right. Because, don't do what? Don't exit out? Oh. I'm telling you that these are not the same. Right, yes. Don't do that. These are two different things. This was saying up 1. This is saying left 1. I want you to see the difference in how you shift it up and down as opposed to left and right. So if it's in parentheses, that attaches it to the X. It's just like, you see your blue sheet says this, but for the one right before it that was vertical, it said this. You see the difference? If it's in parentheses with the X, it's a left-right. If it's outside of the parentheses, it's a up-down. Okay?
Why is it crossed out?
Because I was saying that that's not the same. Don't get it confused. Those are two different equations. All right. Parent is X squared. Tell me which way I'm shifting, left or right? Left, because if I add, it's a left shift. Yes? Left. Oh, wait, what? Left which way? Oh, left how many? Sorry. Left 1. Okay? Because the +1 inside the parentheses. If you add 1, yes, but then you're squaring and you're doing some other things. It'll make more sense as we get into some better equations. What?
This side positive, this is negative, or?
This is negative. Here left.
Negative, positive. Okay, so look what I'm going to do. If you don't need to put the parent on here, you don't have to. I'm going to put the parent on. I think it's especially helpful in the beginning when you're learning it. So, oh my gosh, it's not a sign. It's curved, it's curved. Thank you, Sawyer. Thank you. Ah! Now, take this blue, whatever color that is, and shift it left 1. So every single point shifts left 1, left 1, left 1, left 1. Every single point. Yes? Yeah. Left 1, left 1, left 1. so that my new graph
I still do that when I'm like, when you can't tell me to go. I did that on my driving test yesterday when she said to turn right. I was like,
All right, listen, what's my domain? Looking only at the white one, only at the white one. Stay with me, stay with me. Negative and, that's white. What's my range? Zero. That's right. 0 to infinity with a bracket on the 0. Okay. Probably.
but I don't know what's going on.
All right, shh, guys, stay with me. Can you do multiple translations? In other words, could I slide to the left and up? Yes, I could. I could do multiple translations. I'm actually going to show you that on your packet. Yes. Like,
Or you just don't.
say again?
Like if it was last, you put another plus on the outside.
Yes. All right. Let me show you one more and let me combine them. There's not a C. It's just left, right, up, down. This is a combination. Now, I want to ask you something. Let's see if you remember. If you were graphing this like we learned yesterday and the day before, right? I would tell you to plot the vertex first. And you would tell me that the vertex was 3, 2, yes? Right? Let's graph it, however, by translations instead. And let's see what it looks like, because I should still get the same thing. So tell me, looking at this, tell me what transformations are happening.
Down 2 and
Right,
right 3.
up 3.
Right up
No.
2.
Right 3,
Up 2.
up 2. Right 3. Holy crap, that's the neediest baby I have ever seen in my life.
Baby is suffering.
Okay. Shh. Listen. Look at the transformations and not the baby. Okay. All right. Jonathan.
That's all she does is complain to me no matter what I do.
Okay, look, boys and girls. This is the parent graph, yes? Let's make the little baby graph. Okay. I'm going to shift this to the right 3 and up 2 and to the up. And to the up, to the right and to the up. Right, every point goes to the right 3. 1, 2, 3. And then it also goes up 2. This point has now become this point, yes? Do that with all 3 points. One, 2, 3. Yeah.
They're all wrong. I'm just joking. Yeah, I ate this.
Yeah. All right, look, I hope you were able to slide them all. I hope you are also able to see that if you graph this the way we graphed before, you would have started at the vertex of 3, 2, and if you look 1, 2, 3, 1, 2, my vertex is still where it's supposed to be. I just didn't have to plug in another point, plot it, reflect, connect. I just did the sliding. Well, yeah, you can. Yes, that'll always be the vertex. Yes, you move from there. What's the domain? What's the range? To infinity. Look at your homework sheet at the packet that I gave you. And look at number 1 with me. Everybody look at number 1 with me on the homework packet. We're going to go backwards a little bit with this. Yeah. We're going to do it together. I'm going to show you. Look at number 1. Oh, I'm so glad. Thank you. What is that point? 2, -5. That is indeed 2, -5. All right, this is what yours should look like on your paper. What is the parent function here? Because I want you to see what I want you to do. The parent is, that's right. Because I can tell by the shape of it's either going to be, that's right, it comes to a point. It's either going to be absolute value, quadratic, or linear. Yeah. You write this. Yep. All right, the next one says transformations. Now, I don't have a graph here. I mean, I don't have an equation here. I just have a graph. So tell me from the parent to this new one, what happened? Which way did I move? What happened? What did it do? I moved right 2 and down how many? 5. No, order doesn't matter.
Wait, Miss McGee, you have to write a formula in transformation. So don't write what you wrote.
No, oh no, the next, look at the next line.
Doesn't matter if you left or right or up.
Doesn't matter. Doesn't matter. All right. Can everybody tell that I am right 2 and down 5 on this graph? Yes. But it's absolute value, not squared. All right. Write the equation using these transformations. In other words, write the equation of the graph that's given. Knowing how it slides, write its equation.
I'm confused on this one.
X minus 2, because that's right. All right, so look. Look at the blue sheet. Look at the blue sheet. See where it says right? See where it says right? What does it tell you to do with the C? Add it or subtract it on the F on the first column. It's minus there. That's why. The new, everything's based on the new. So now what is your vertex here? 2, -5. What is your domain? Left to, all of these will be negative infinity, infinity on domain. What about the range? Given the graph and asked to answer the questions. When you hit number 4, you're given an equation and not the graph. You have to make the graph.
Look at it went right.
It went right 3 and down 1.
Oh, I counted right.
Okay. Pick one from 4 through 9. Number 6. They all are the same difficulty. Don't think that they're not. Some of them only 1 through 11. Some of them only have 1 translation. Some have 2. Ones like number 7 only have 1 translation. That one's just going up. Okay. Y'all want to do a quadratic one? Okay, let me run through this one and then I'll hit a quadratic. All right. Here, so the first thing is the parent function. What's the parent? That's right. What transformations are happening? Left 1, down 3. Seriously, y'all, the translations ones, you should not get bogged down on homework. You should not spend more than 15 minutes on your homework on this. Like, I don't want you to think, normally I try to give you time to get it done, but I don't want you to think that this is, I would graph it before I do domain and range, okay? So if I graph this, if I take the parent and I move left 1, down 3, left 1, down 3. Now, if you need to graph the parent to see the slide, then graph the parent. Yes. There's my new graph. It's moved left 3, left 1, down 3. Every point. Left 1, down 3.
So we're supposed to plot like the original one.
You do not have to do the original unless it helps you to see the original there beside it. What is the domain? What is the range? -3 to infinity. Easy, yes? Okay. 10 or 11, pick one. 10, because it's a quadratic. This time it gives you the transformations, but it doesn't give you anything else, right? So I've got to come up with everything. So it says quadratic function, which means my parent is the x squared. Yes. Yes, yes. All right, so I'm quadratic, but I'm up 2 and right 4. What does the equation look like? What? X minus 4, that gives me the right, plus 2. That gives me the up 2. Yep. What do you mean? No, you couldn't distribute that. And you don't have to expand this. You don't have to do anything. You literally leave it here. This is called transformed form. So it's just allowing you to go from the parent to the graph without having to do anything else. So don't try to do anything with it. Don't try to rework it. Yeah. Yes. This vertex is 4, 2. Because every point slid over 4 and up 2, right? So this is 4, 2. What do you mean? Everything x is opposite. So if you subtract from x, that means go right. If you add to x, that means go left. It's the opposite. Whatever your brain thinks with x, do the opposite. The y is the same. What's the domain? I'm looking at the white one here. -∞, infinity. How about the range?